8th grade lesson 2.4. This is putting together all the stuff that we've been kind of looking at. It's operations, handling operations with scientific notation. So one thing I would suggest is that page 36 of your textbook that has all those tricks to do with exponents. You're going to want to have that handy, have a bookmark there. And now that we understand scientific notation, we can use the properties of integer exponents from page 36 to solve some of those very large problems without dealing with all those zeros either in a calculator or on our page. So I think this is where everything, hopefully this is where you feel like everything comes together like, oh, I see why they do this now. So we'll use this first example. This first example deals with adding with scientific notation. So it has this table that shows the populations of 3 different countries, and their question is find the total population of these countries. And so you guys know that if we're finding the total of something, that we're adding that up. So we know we're going to add these numbers together. Okay, and so there's our numbers, and you probably remember from the previous years that anytime I'm adding up to anything with decimals in it, I've got to line things up. So here's where we have to be super, super careful. I can't just line up my decimals because remember that decimal gets moved around based on these exponents. So in order to line up decimals in scientific notation, we have to get all of these exponents to be the same, which is easy. I just need to move that decimal around a little bit to get that to be the same. Well, this one's already the same as that one. So to the 8th power on these two. It's this one that's not quite the same. So I would just move that decimal once more over, and that would be its 8th spot over now. And now I would have 10 to the 8th power. So it's going to look like this. Okay, so what I've done now is I moved this decimal over 1 so that I can make that an 8. There it is. Then I was careful to line up my decimals and my place values. And if it helps keep us nice and in order, we'll put some zeros here. There we go. Okay. Then I add those up. I'm going to get an 8, 3, 3 plus 1 is 4 plus 1 more is 5, decimal straight down, and 3 plus 0 plus 1 is 4. And this doesn't change. This is all still to the 8th power, so I don't have to add that up. That's my scientific notation. That's how you add with scientific notation. So step 1, get the same exponent on the 10 to the whatever power. That's just adjusting those decimals so they line up properly. Then you add these pieces together, but you leave this alone. Look like it might be difficult, but super easy. And way better, in my opinion, way better than the second option. And the second option is just to list out all of those numbers. So I would have this 3.1 times 10 to the 8th would be 3, 1, 2, 3, 4, 5, 6, 7, 8, comma, comma. Then my 3.38 to the 7th power that's going to be 2 of these spots count for that 7, right? So it's going to be 1, 2, 3, 4, 5, 6, 7. So 5 zeros. So I'm going to go 1, 2, 3, 4, 5, 8, 3, 3. That's 8, 3, 3. Then I would change this one to be it's to the 8th, so that counts as one of them. So I'm going to need 7 more zeros. So I'm going to work backwards so that I keep things lined up. 1, 2, 3, 4, 5, 6, 7, then the 1 that's there, and then the 1 that's in front there. And then I would add it all up. I would get my answer, and then I would convert it back into scientific notation. But if we're not super neat about it, these and I will tell you, when I did it in my notes, I had to erase things and go back because I got it all mixed up. So the answer, I've run out of room at the bottom, but when you add that all up, we end up getting 3.453800000, and then we still have to convert it back into scientific notation. So I'm going to want to move my decimal 1, 2, 3, 4, 5, 6, 7, 8 spots so that I have 4.538 times 10 to the 8th, which is the answer we got doing it this way. So, in my opinion, because this leads to errors if we don't line things up perfectly, and once you get used to manipulating these around, this is a pretty simple thing. It just takes some practice. Once you get used to it, it's quicker to do it this way. And it is already in scientific notation. My answer is done, so I don't have to convert it out, add it, and convert it back in again. So now let's take a look at how that works in a multiplication or division sense. So we get this question about the sun making an orbit around the center of the Milky Way. It travels 2.025 times 10 to the 14th kilometers, and the orbit takes 225 million years. At what rate does the sun travel? So we're talking about, when they say rate, remember, we're talking about a distance over time. So they give us the distance, 2.025 times 10 to the 14th. They give us the time, 225 million years. One of these in scientific notation and one of these in standard form. I need to convert one to the other. And I'm going to convert this one to scientific notation because I recall, and you would only recall if you looked at page 36, or remembering like there was some sort of trick with exponents. Remember the trick with exponents, a to the m divided by a to the n can be done as a to the m minus n. Refreshing of memory, if I have a 10 as my base, and it's raised to this power divided by the other one that's raised to a different power, the answer will be the base with raised up to the m minus n power, the difference between the two. So I could use that here. So let's go ahead and do that. So I'm moving this decimal from the end in 3, 6, 7, 8 spots. So this is now going to be 2.25 times 10 to the 8th power. I'm putting that 2.025 times 10 to the 14th back on top again. This is a division problem. And now, instead of dividing with all these crazy zeros that both of these would end up having, I'm just going to get my calculator out and divide 2.025 divided by 2.25. Calculate, and I am going to get 0.9. All right, so that's the division of that. Now I'm using this to help me with this. My base is the same, so I can use that. So I'm going to be doing 14 minus 8 for that exponent there, right? So it's going to be times 10. 14 minus 8 is 6. 10 to the 6th power. There's my answer. That is the rate. In kilometers, erase that. In kilometers per 1 hour. Keeping in mind, though, that real scientific notation wants a number between 1 and 9, that are inclusive of 1 and 9, a single digit in the front. So we make the adjustment. Let's pull that back. That means I'm taking one of those 6 spots back away. So it's going to be 9 times 10 to the 5th kilometers per hour as the exact answer, or 9.0 times 10 to the 6th, however you want to write it. But I just moved that decimal once, so instead of 6 places over, it's now 5 places over. So you'll start getting comfortable with this number just being a manipulation of your decimals. All right, and then this one's going to use multiplication. I'm just telling you ahead of time, but I'll show you how I knew that in just a minute. And remember that trick with exponents for multiplication was if I had a base to the m power, same base to the n power, and they were being multiplied together, I can just add those exponents up, a to the n plus n. So I'll show you how that works in scientific notation. First, let me show you how I knew already that this was going to be multiplication one. Well, first, because I sought one out, I looked for one so that we could do it as an example. But here's how I did that. Light travels at a speed of 1.86 times 10 to the 5th miles per second. I see miles per second, and my brain suddenly goes to that proportional relationship thing. So if you have one proportion and it equals another, you can multiply those crosses, those opposites, to seek out the answer, and it will give you the answer. So right away, my mind knows, like, I'm going to have a set of handlebars or proportion next to another one. It takes light from the sun about 4.8 times 10 to the 3rd seconds to reach Saturn. Find the approximate distance from the sun to Saturn and write your answer in scientific notation. So let's write this proportion in miles per second singular, 1 second. So I'm going to write 1.86 times 10 to the 5th in miles per 1 second. That is in proportion with the amount of seconds. Thankfully, in this case, they gave it to us in seconds, and we don't have to convert it to minutes or anything like that. The amount of seconds here. So on the same floor down here, I'm comparing seconds to seconds, so I have to put seconds down there. So that's going to be 4.8 times 10 to the 3rd. And their question is, what is the distance? Well, distance is miles, and since that's what I'm seeking, that gets the variable. All right, once I've set that up, I don't need to know which calculation I'm doing, because this just tells me. Remember, we multiply those crosses. 1 times x is x, easy. And then 1.86 times 10 to the 5th times 4.8 times 10 to the 3rd, well, we'll have to calculate that, but let's write it down. I'm going to put those in parentheses for now. And recall that every operation is multiplication. Multiplication is commutative. I can move it around if that's the only operation that's there. I can use the associative property, just meaning that I regroup them, and that's what I'm going to do right now, because there's no other operation to stop me from doing that. There's no subtract that has to go second, or something else that has to go first. Yes, parentheses are here, and in order of operations, you know those go first, but every operation throughout the whole thing is multiplication, so we can get around that. So what I'm going to do is I'm going to regroup this guy with this guy, and then I'm going to put that 10 to the 5th with the 10 to the 3rd. So regroup using associative property. It will be 1.86 times 4.8 times 10 to the 5th times 10 to the 3rd. All right. Then I just get my calculator out to calculate these two. Calculate, calculate, calculate. And I get 8.928 on the calculator. And then over here, I'm using this rule because I have the same base. And in scientific notation, you're going to have the same base, right? It's always going to be that 10. So this is to the 5th power, this is to the for that, and to the 3rd power for that. So I add them together times 10 to the 8th. And my answer is already in scientific notation. That is how, and the question was for distance, so my label is miles. That's how many miles it will be. 8.928 times 10 to the 8th. What is that going to be in real life? 8.928. That's 1, 2, 3, 4, 5, 6, 7, 8. 892,800,000 miles. That's a lot. Big, 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 big. We don't want to deal with all those zeros if we don't have to. The last part of the lesson talks about using scientific notation on a calculator. There's usually like an E button, or capital E, or a capital EE, or a lowercase ee, or something like that, that will take this number. So you would type in 1.86, and then you would put the E, whichever form it was on depending on the calculator, and then you put 5, and it would convert that into standard. And then you would say times 4.8 EE or whatever the symbol is 3, and it would convert that into standard notation. Then it would divide it for you and give you the answer in standard notation. So you'd have to convert it back into scientific notation. I'll tell you, as you get more comfortable with this, you will probably prefer to just leave it in scientific notation, do the tricks, use the calculator like we did on this part, get that answer, and then do the trick for this one, and then your answer is still in scientific notation. So it's more than likely after you practice a few of these and start getting comfortable with it that you'll be like, I'm just going to leave it like this. So just know there is the possibility of being able to use the calculator on there, but for me, I just find it's easier just to leave it and use the tricks to do it. So with practice, this will be much more clear. So keep practicing and use me for help if you need it.